Hello, let's take a look at your 8.2 and 8.3, or LT8, MT8, LT2 and 3 seminar. And what we want to learn in this seminar is determine whether two shapes are similar. We want to visualize and describe and solve problems involving the perimeter of similar polygons. And we want to use the angle-angle similarity to show triangles are similar. First off, let's start with similar polygons. Remember, similar means they look the same. In order to look the same, their corresponding angles have to be congruent. But they don't have to be the same size, so their corresponding side lengths, they're going to be proportional. They don't have to be equal. Then if we, just like most things we've done, similarity also is reflexive. That is, a triangle is always similar to itself. It'd be actually congruent to itself. Symmetric property, it says that, hey, if triangle ABC is similar to DEF, well then DEF is similar to ABC. And then we also have the transitive property. In the transitive property, let me switch colors here. I want something light. Yep. Okay, we'll go with light shade there. Transitive property of similarity says, hey, if triangle ABC is similar to DEF and DEF is similar to XYZ, then triangle ABC is similar to XYZ. Just like we've done with congruence and everything other property we've done. Now, on our first example, we have two shapes that are similar. I want to list the pairs of congruent angles. We can look at that shape, and I can look at the name. Notice angle A and angle P correspond. So that tells me angle A and angle P, they're congruent. So angle A is going to be congruent to angle P. I could just go around my shape and notice that angle B and angle Q, they correspond. So B and Q. So I could say, let me see if I can make this a tad bit thicker here. There we go. So we're going to say angle B is congruent to angle Q. And we'll go angle C is congruent to angle R. And angle D is congruent to angle S. So far, that's just like we did with congruence, isn't it? Here's where it's different. Shapes are similar. Sides are not. So if I want to compare my sides here, like AB, that corresponds to PQ, doesn't it? So I'm going to say the ratio of AB to PQ, well, that's the same as if I do BC, I'm just going around now, would be congruent to QR, or equal to QR. And then, keep on going after BC, I see CD is in the same relation as RS. And that's the same ratio as AD is to PS. I could have those switched around just as easily. So I could say the ratio of PQ is to AB. Doesn't matter the order we do them. As QR is to BC, as RS is to CD, as PS is to AD. I get the same thing no matter how I do that.